Thank you all for joining today. We have officially kicked off this series, Take30, with a data scientist. And before I get started on today's topic, I put down here the other topics that we have going on this week. So on Wednesdays at 11, we'll have Take30 with the data advisor. So tomorrow, the topic will be just demystifying the cloud, AWS cloud warehousing basics. And then every Thursday at 10, we'll have Take30 with the BI expert. This week, it'll be Ask Me Anything about Cognos Report Studio. So love for you to sign up for those series as well if you haven't. A little bit about me. I'm Pam Naskar. I lead our data science practice. Been with Ironside about 5 years. Worked in pharmaceutical advanced analytics before that, in market research. Way back, I got a doctorate in psychology and did some academic research. So that's just kind of me in a nutshell. We like to start our presentations by reminding ourselves and our clients about our mission statement, which is to help our clients use data to make better decisions about their business. That is pretty much the definition of AI, doing that with some advanced methodologies. And then I also want to take a moment to talk about our capabilities at Ironside. In advanced analytics, we actually touch every wedge that you see on here with AI. And I wanted to talk a little bit about our legacy in the data science team at Ironside. And it's really about helping organizations get started in AI. We certainly come into organizations who are more mature in their AI development and capabilities and can help break down some bottlenecks and plug in where they have gaps. But a lot of the work that we have done from the very beginning is helping them figure out how to get started with AI, what are the use cases they should be using, how to design their solutions. We help to build them, deploy them, help them figure out where the gaps are, and maybe they need to step back and look at some data governance, master data management. And so really we work with all of the practices and centers of excellence within Ironside to deliver these solutions. So Ironside really isn't a company that has a specific solution. It's looking for someone that has that problem to match up. It's about the problems and the goals of your organization and bringing all these capabilities together to find the best solution for it. But I wanted to talk specifically about that kind of legacy and helping to get organizations started in AI, because that is today's topic. And I think it's important to understand that we come at that question of how do I get started with AI with a certain perspective because of our history in doing that with so many different companies. I had a conversation just this week with a potential client who said something very familiar that I hear frequently. We know we need to do AI, we know we need to get started in it, but I don't even know what questions to ask, right? They're very early in AI maturity. And because I was looking to build out this session for this week, I thought that might be a good place to start. What are the questions that you should be asking? What are the questions that we hear most frequently? And even if we don't hear them, we know need to be addressed and answered. And so I'm structuring this talk today kind of with these 6 questions that come up very frequently about how do I select the right use cases? How do I get some support within the organization and build company culture around AI? When should I hire data scientists and what type of data scientists? The technologies that you should invest in. What don't I know? I hear that sometimes because, you know, what are my blind spots, essentially? And then how do I really just get started quickly and in a cost-efficient way? So the first question, how do I select the right use case? This is sometimes an undervalued question. People just, sometimes an organization will have an idea of a use case. Sometimes there's a BI or BA team who is driving the transition and the transformation to use AI, and they're just looking for problems that can be solved. And so they're going to gravitate towards, you know, a quick win and what they have the data to answer. That makes sense. I'm all for the idea of getting some quick wins and starting with use cases that you have some viability for. But a common misstep is to kind of start on the right-hand side of your screen and look at the data that you have and say, what can I solve with this data? What problems can I solve? And then try to go out and sell those back to the business. It's a misstep because sometimes you end up investing a significant amount of time and effort into going down that path just to discover that no one needs that particular problem solved, or maybe they do, but they have other burning questions, or there's just not a lot of support for, or there's internal politics and you're stepping on someone's toes because you're solving a problem they wanted to solve, or something like that. So Ironside's approach to use case development follows more of a right to left methodology, we call top down, or left to right in this case, right? We want to talk about goals and outcomes and really start at the top with our questions. What are the goals for your business? What are your pain points and challenges? What's preventing your success? What are the opportunities for success? And then going over to what are the decisions, the actions that make up those goals and that get you there. And really working from left to right through this list, eventually getting down to the data and saying, okay, we know what the big problems are. We know what you need to solve for your company. Do you have the data for it? Is it good enough? Is it good quality? Do you have enough of it? Is there external data that you could use to supplement it? So that gives you more of a complete picture, and you know and can prioritize the right path to follow. Now, I'm not going to talk too much about use cases specifically, because 2 weeks from today, we're going to have a session just on that. And that's how important it is to really spend some time thinking through AI use cases and how to prioritize them. But the other thing that I wanted to say about the use case is really that whole work and that effort to go through interviewing stakeholders and understanding the pain points, challenges, what's important to your organization, and getting down to the data leads you to an exercise like you see in front of you, where you can actually plot use cases, and you can imagine a big whiteboard and actual use cases written on sticky notes, and you can plot them. After going through that whole exercise I just showed you, you can plot them on business viability. How important is this to my organization? Is this going to actually bring value to us? And on the y-axis, data viability, right? We've looked into this. Is there data to support it? Is it good data? Would I have to go out and get external data, etc.? And this allows you to quickly and easily, after you put this all up there, see what are the priorities for AI? What should I focus on first, where I know that the data is available and I know that there's support for this within my organization. I know there's a need for it within my organization. On the top left hand, you see those value traps. That's where, these are problems that could be solved because there's data, but there's actually not that much support from the organization or need for it. And on the bottom right, you see data remediation. This is a very valuable quadrant too, because you can look at this and say, these are the use cases that are important to my business. We need to investigate them and put some work into them, but we have to first pause and think about cleaning up some data or changing some data governance or data collection practices, or we need to find some external data. And so it's worth putting some work into those before you move forward. So this is a methodology that Ironside recommends and we like to use to make sure that before you invest a lot of time and effort building out AI assets, that you make sure that you're going down the right path and that you're going to end up with ones that you have buy-in and support and excitement for at the end of the day. At the top of the screen, the header is, how do I build support within my organization? And that's not a mistake. I think the use case question actually leads very well into this question around company culture, because this is essentially how you do that. One of the most common things we hear from clients is, our company culture just isn't ready for this, or the executive sponsorship, is a little on edge about this. And I'm going to play the psychologist card and tell you that people are afraid of what they don't understand, right? And so the more you educate people, get them involved, talk about this, the more comfortable they're going to get with AI, the more they're going to understand the potential value for their particular business. And so all of this, going back here, doing some education, getting people involved in the interviews, talking to them about it, having them in the room when you prioritize use cases like this, have them write down the ones that are important to their particular business unit or functional area, plotting it, getting them to visually see the balance between data viability and business viability and everything there. That's one of the strongest motivators for company culture change and getting them to understand and accept that AI is a path forward for their organization and they're moving in that way, and it can be very beneficial to them. So the other thing I wanted to say about company culture is that it really isn't just something that I'm saying. I hear a lot in this O'Reilly article, and this was updated in 2020, and it's still the #1 cited reason for a barrier to AI adoption is that the company culture doesn't recognize the need for it. And so my recommendations for how to build support is this: it's educating them, it's getting them involved in the process, in the prioritization process, so that all the stakeholders, business units, executives can hear the same information and get that education and be involved in it. Also, quick wins. Like I said, I think that's a great way when you're looking at your use cases. You do want those quick wins that you're not waiting, 6 months before you see some value on, but you're starting to get some excitement and build up. And that's one of the reasons that selecting those early use cases is so important, because you don't want to pick the huge burning issue for the organization, because if it doesn't work out, people start to go, oh, AI, it's not for us, right? You also don't want to pick something that nobody really cares about and it's not of that value. And that's why that balance is very important early on in helping you build that support for the company culture. And be agile. Don't be afraid to pivot away from something that's not viable. Because again, if you keep pushing down a path where there's resistance, or the data is just not going to support the use case, right, you're going to just burn resources and time and money. So be agile, move on to something else, test out different use cases. Another question is about hiring data scientists, right? You need people to do the work, or you need to skill people up internally. Let me tell you first what a data scientist is. It's kind of a loaded person, right? That doesn't really exist with everything that they need to be. They need to be a business expert. They need to be a statistician and know how to do machine learning. They need to be a programmer. There's other things. They need to be an educator. They need to evangelize what AI is to the organization and talk to them. They need to be self-driven and learn the new technologies that are coming out all the time. An experienced designer, a solution architect, a data engineer. So when I'm hiring a new data scientist, my HR team probably gets frustrated because it's not the same description every time. I'm not always looking for the same person, because you need to understand that this isn't just one person. There's not one profile that fits everyone, that everyone comes at this with a strength in a different area. And so what you need is a well-rounded team of data scientists, not a single individual. And so based on who I have on the team, that's going to impact who I need to fill in. And so 2 issues that I sometimes hear from organizations that have started to move down this path and they've hired data scientists. One is they say, I have a team of data scientists, I have a bunch of PhDs, they're great with machine learning, but we're struggling to get anything into production. We're struggling to get it back into the business or to scale up from there. And that's because PhDs, we're good people, we're great, but you have a bunch of like-minded people who all have the same skill set. And again, data science isn't an individual, it's a team. And so my recommendation is hiring a well-rounded team where you have people who come at it from the academic side and really know the fine points of machine learning, but you also have people who have a little bit more of a computer science background who can do the data engineering and deployment. The other issue I see frequently is people say, well, we hired a data scientist, but after a year, we either had to let them go or they left because they were bored. We just couldn't get them enough work to do. And the issue there is that you as an organization, you want to engage in AI, you want data science, and so you hire a data scientist expecting them to know how to get started. That data scientist, often in this case, I see them hiring someone fairly junior. They're coming in looking at you as the business to give them use cases and tell them what to do. And you're looking at them saying, you should know what use cases are and how to develop an AI use case. And the reality is they probably are more of a statistician and programmer and haven't worked a lot in business. They don't know those questions to ask that I talked about a few slides ago. They don't know how to extract those business use cases and get them going and think through the whole production and getting them back into the business. So I see both of those issues coming up when people, when organizations say, we want to move into AI, let's hire a bunch of data scientists and let's buy a bunch of technology, and then still struggle to get started. So that's just something to keep in mind, and I'm going to put a pin in when do you actually hire a data scientist for a minute. And I'm going to move to talk about technology for another minute. So this is Gartner's Magic Quadrant. You've probably seen this with other analytics evaluations as well. Couple things to say about this. One is, if you've seen their Magic Quadrant for data science machine learning platforms before, you may pick up on what I did this year, that this is very crowded, right? I don't think I've seen it quite as crowded before, where everybody's kind of in one cluster. I guess they're straddling the line between leaders and visionaries, but there's not like one or two outstanding leaders in the pack. Working for a consulting firm, one of the benefits is that we are tool agnostic, and I've worked across a lot of these platforms. I know some of the strengths and weaknesses and have some preferences, but it's still very challenging to just answer that question for a client. What technology should I use? Just tell me which one to buy. And that's because it really depends on the organization, your long-term goals for AI, who's going to be using this. Are you trying to skill up people on your BI team? Are you looking to hire a very experienced data scientist? Are you looking to have a whole team working on this that need to collaborate, or just, you know, a small team of one or two people? So it's a difficult question to answer. And so instead of just, you know, highlighting one or two, I have some of my opinions, and I think every data scientist probably has different opinions on platforms and technology that they've used. In thinking about technology, I would say that end-to-end platforms are very helpful. It is nice to be able to work in one solution and not have to do data wrangling in one and pull it down and bring it back up into another one. But I wouldn't go so far as to say that you should always have a closed system, when, you know, sometimes bringing in best in class is helpful. Data Robot can be a great accelerator for some places. You know, Snowflake can be great to increase the agility. So if you're working on AWS or Azure, you can bring in something like that too. So, so again, I prefer the end-to-end platforms, but I think there's times when, as long as tools can work well together, you can do that. Coding optional platforms are really valuable if you have some excellent BI talent that you want to skill up into data science. Maybe they have some machine learning background. We've done that very frequently. We've worked to help pick technology and then train some analysts in best practices for data science and then the tool itself. So we'll work hand in hand with them to deploy their first algorithm and then kind of hand it off. So things like IBM's SPSS and Alteryx are really good with that. Data Robot's another one that's valuable there too. I would also say I prefer going to the cloud over desktop solutions for AI. The cloud computing costs can't be beat, and also the agility. And I think I mentioned using something like Snowflake. So it's not a machine learning platform, but having a cloud warehouse offers a data science team agility and the ability to just work at a speed that they need to work in and spin things up and down without interfering with the rest of the environment, which, you know, DBAs don't always like, and we have to buy them a lot of pizza because data science work can be very intrusive into that. And so this kind of gives some flexibility and freedom. So again, my last piece on technology is just, it probably shouldn't be your first step to go out and invest in a lot of technology, invest in data scientists. But again, I'll put a pin in that and kind of come back to it. Just real quickly, what don't I know? I get this a lot, and I'll just quickly go through this to save some time, but these are some common blind spots that an organization may not know about. The first one, the long-term care and model maintenance. An AI model is not a piece of software that you develop and it's done and you can put it out there. It really is a living, breathing thing. All models will drift over time, and you need to have a team managing that and maintaining it. If something happens in the economy, if, you know, there's a global pandemic, for example, and everything shuts down, if anything changes, when the SAT scores, they change their whole system. I had some higher education clients who were doing enrollment management and everything broke, and that was the cause, because something changed in there, right? And the model's built for a certain situation, and unless you have that continual learning going on, those models will break and be affected. So you have to keep an eye on it. You have to be aware of it and know that once you do all the work to build this algorithm, you still have to continue to care and maintain it and have someone to do that. Feature stores, that's just the idea of having a central location for features that you've developed for a use case that could be used for other use cases, right? Because what you do is you spend like 70% of your time on a use case engineering features for that model, and then you do another use case and another use case. And if you can build it in a way where they can all leverage the same features so that you're not recreating them and possibly doing them differently each time, then it can save you a lot of time and be efficient. So I think that's something that actually is kind of a fairly new concept, even though it seems like something we would have been doing for a long time. Accuracy and performance balance. I think Netflix had the example. They had a competition, probably on Kaggle, to develop their recommendation engine. The winning algorithm that was most accurate actually never went into production because it was so onerous to actually execute. So you don't want to build a model that takes 12 hours to run if it needs to be done nightly, for example. So sometimes you just have to understand that you might be giving up some accuracy for performance, and you have to keep that in mind. And again, that's when you hire someone fairly junior, they may not know that as well. So that's another thing we run into where someone hires a data scientist. They're fairly new to doing this, and they don't understand the execution and production issues that they may run into. Technical stuff I won't describe what overfitting and target leakage and stuff is, but again, when you're scaling up someone internal to be a citizen data scientist, there are things that they need to keep in mind so that they don't build a model and then realize it's overfit or there's target leakage and it won't perform well in the real world. Scaling is another thing, right? It's great to get some quick wins, get those AI use cases out there. Once you have a few of them in production, though, you realize very quickly that you need some governance over all of this, and you need to be monitoring and maintaining them. So, so moving on, the quickest and most cost-effective way to get started. There's a couple different types of clients that we work with. Like I said, we've been doing this for a while, helping organizations get up and running. Some of them have a lot of finances, right? They have money available to spend, and they want to buy the technology, and they want to hire the data scientists, and they want us to help figure out how to do that and what course, and we can do that, and they can be successful. But I would say like 2/3 of the organizations that I talk to say, I don't have the money for that, or I don't have the buy-in to go and spend that right away, right? We need some quick wins. We need to prove out that this is right and that it will work for our organization before I can get funding for that. And that's one of the reasons we built the Send AI. So I am going to kind of make this a little bit of a sales pitch here, but this because we built this last year. This is our data science as a service solution, and built it specifically because there were so many of those clients that I was speaking to that struggle with that early getting up and running. And this takes the technology discussion, the hiring a data science discussion, or hiring our services, kind of out of it and puts it on the side, so that you can say, before I invest in all that, you can use our infrastructure. We'll accelerate some of the pieces of the data science process. You can use our resources, our data scientists, data engineers, solution architects, etc., so that we can help you prove out value, get some models either tested and validated, or even fully productionized and host them and maintain them for you. So data science as a service from Ironside is built as a way to either offload everything so that we host and maintain it long term, or be a place where you can just test it out, get some approval, some buy-in, and then start building that on your side. So with that, let me pause there. Make sure I haven't used up too much time, because I had a lot of information, so I apologize for talking really quickly, but let me pause and open it up for any kind of questions. And again, I did go through things quickly. If you'd want more information kind of in a one-off session, we'd be happy to set up more time to go into any of this, and helping you figure out the best way to get started for you, whether it's data science as a service or whether it's building some services on your own environment.
So Pam, we did get a question in the chat box about how Snowflake could be used in a use case and how data scientists could leverage a technology like elastic cloud storage?
Yeah, so what I've found cloud computing cost efficient, but also extremely agile. So a lot of times when I'm working on my client's environment and I'm providing the data science services, there's some time and some effort to build the space that we need in their data warehouse so that I can build a feature store, right? So that I can test on production data. Sometimes we need that. It's very intrusive, right? And so working with Snowflake, it's extremely agile. We can share sections of data without having to, fully build something really big. I can create a lot of tables that I won't need long term. I often go in and request a space in a data warehouse, and then at the end say, okay, but we've productionized this, so these 30 tables you can delete. I don't need those. So I don't need to do that in Snowflake. I can spin things up and down as I want. It's very elastic, it's very flexible and agile. So it allows me to work without having to go through the DBAs for a lot of what I need to do that doesn't need to exist.
Well, as Pam said, just send them, to us at here-to-help@ironsidegroup.com or to Pam directly, and we will get back to you if anybody has any questions. And we hope that you join us for this weekly series.